Question number 19. A car driver makes a journey in a straight line from A to B, starting from rest. The speed of the car increases to maximum, then decreases until the car is at rest at B. So it starts at rest and also reaches B and goes back to rest. The distance traveled by the car t seconds after leaving A is given by this. Okay, so we know x equals 0.40117 400 t cube minus 3t power 4. Okay, we need to find the distance AB. So we don't have a value of t that we could substitute here. So what we need is the value of t when this car reaches B. And when the car reaches B, we know speed is 0 again. So we first need to find the expression for V, equate it to 0, and get the value of t. And then substitute that t back in this equation to get the distance AB. Okay, so how do you find V from X? We derive it. So 0.00000117 times 3 times 400 would be 1200 t square minus 12t cube equated to 0. Okay, so this gets eliminated because it gets divided by 0. I'm taking t square common. So I get 1200 minus 12t equals 0. Again, t square equals 0, which gives us t is equals to 0. And 1200 minus 12t equals 0, which gives us t is equals to 100. So first at t is equals to 0, the speed is 0, which means at A. And then at t is equals to 100, the speed is again 0, which means at B, time is 100. So now we substitute 100 here and get the value of the distance AB. So x would be 0.00000117 400 times 100 cubed minus 3 times 100 power 4. This should give us 1170, which is the distance between AB in meters. Okay. Part 2 is find the maximum velocity. Okay, maximum velocity. At the maximum velocity, the acceleration is 0. So let's find the expression for A and equate it to 0. So A would be dV upon dt, which would be 0.00000117. This becomes 2400 t minus 36t square. Okay. And when the speed is maximum, the acceleration is 0. Let's find the value of t from here. Again, this coefficient gets divided by 0 and gets eliminated. And you equate this to 0 next. Take t common. T would be equals to 0. And then we'll be left with 2400 minus 36t equals to 0, which would give us t equals 66.66666 seconds. 66.6 with the recurring dot on 6. And we need the value of V at this time. So now we substitute this time in this equation for V. And when you do that, you would get a final answer of V equals 20.8 meters per second. So now we know that when the time is 66.6, I'm just collecting the data because I know in the end I have to make a graph as well. So somewhere in between A and B, the velocity will be maximum, which would be a value of 20.8. Okay, find the acceleration of A of the car as it starts from A. Okay, so that means the initial acceleration So that would be when the time is 0. So when time is 0, you substitute t is equals to 0 here, and you get a is equals to 0 as well. So at t is equals to 0, a equals to 0. So that is the answer. Next, it says, whereas it arrives at B. So now you've used t is equals to 100, because we know when it arrives at B, that t is 100. Now substitute the value of 100 in this equation, and you should get negative 1.404 meters per second square. Meters per second square. And this is also meters per second square. Okay, that's done. Last part says sketch the velocity time graph for the journey. Okay, so V has a cubic expression, in fact, negative t cube. So it's some graph like this. Okay, let's substitute these values. When v is 0, t is 0, that's here. And then when v is 0, t is 100, v is 0 again. So write 100 and v is 0. And then we need have this point as well, that when t is 66.6, somewhere, roughly somewhere over here, the time is, the velocity is at its maximum, which is 20.8. So the graph is something like this. It's part of a cubic curve. So like there's more here, there's probably more here, but this is the graph within 0 to 100. And you may write 66.666 here. And label the x's. This is time in seconds, and this is velocity in meters per second. In fact, this was a negative x cube graph, so it would be something like this. I think initially I changed it into plus x cube. Okay, that is it.